Welcome to our Unit 6 review here. We'll be looking at the general ideas of everything we covered in Unit 6. Reminder, for your upcoming test, you can bring a 3x5 note card, take your notes that you got in your notebook there, any examples you've got, any work you've got. You can put anything you want on the note card, front and back. Also remember that at the end of every unit lesson, Unit 6.1, 6.2, all the way up, there is a web address to Digital Practice. So if you want some instant feedback, you can look at a lesson, go back and practice right there. It's multiple choice questions, and you'll find out right away if you're right or wrong, and spend 5-6 minutes on each one. Might help you quite a bit. Alright, the zero product property is where we're going to start. Remember, the zero product property simply says if two numbers are multiplied together, one of them has, and the product is 0. If you multiply two numbers and the answer is 0, then one of them has to be 0. So let's take a look at an example here. What if we have x squared minus 64 equals 0? Well, I'm pretty confident that you can find the roots here, because we know that we want to simplify first and then factor the equation. Now, in any one of these, I would like you to stop the video and try it on your own, and then I will go through the answer with you here. So why don't you give this one a try. Remember, you're looking to keep the equation set equal to 0 and find up to 2 roots that would make this true. Alright, well, here's what I did. I went ahead and just said I'm just going to use the easy x here. I know that there's no b value, so the coefficient of x to the first must be 0. C is negative 64. Two numbers that add to 0 and multiply to negative 64. That's right, positive 8 and negative 8. Go ahead and write that down like we would from Unit 3. Set it equal to 0. And then solve for both cases. So in this case, we end up with x plus 8 equals 0. This is going to subtract 8 from both sides, and we end up with x equaling negative 8. Set x minus 8 equal to 0. Add 8 to both sides, and we end up with a solution set. X must be either negative 8 or 8. Either one of those, of course, would make the answer true. If you put 8 in here, 8 squared is 64. Subtract 64 is 0. Negative 8, square it. You also get 64. Minus 64 is 0. Good. Alright, next thing we're going to look at is the quadratic formula. This, of course, is our song. If you have that song stuck up here where we've been practicing and so on, then you're going to be really good to go. Don't forget to remember that this particular formula, anytime a quadratic is set equal to 0, you can use the quadratic formula to solve pretty quickly. Solve by using the quadratic formula. 2x squared plus 3x minus 5 equals 0. First of all, what do we want to do here? We want to identify a, b, and c, plug it into the formula, and go. So right about now, why don't you hit pause, go ahead and identify your a's, b's, and c's, and have at it. How about this? How about a equals 2, b equals 3, and c equals negative 5? Okay. Remember, our formula tells us it's the opposite of b, plus or minus the radical or square root of b squared minus 4ac, and all of that is over 2a. So let's go ahead and plug our values in, shall we? And hopefully you plugged them in. Just do your work like you normally would. Remember to take care of the easy stuff first. Clean up what's inside that radical sign there. So here, 9, multiply backwards. Negative 5 times 2 is negative 10. Negative 10 times negative 4 is going to give you positive 40. So I'm looking at 9 plus 40. Just intuitively, you'll want to add what's inside the radical sign there, and that'll clean up to a nice easy number like 49. Now, of course, we still have a little more work to do. What is the square root, both positive and negative value, of square root of 49? Well, that's, of course, 7. When we can't simplify the numerator any longer, split it into 2 separate equations here and clean them up. So we're going to get negative 3 plus 7 over 4 and negative 3 minus 7 over 4. This red plus and red minus, of course, coincide with the plus and minus here. Alright, Now, just do your math. Looks like 4 over 4, so x is going to be 1. Looks like negative 10 over 4. X is negative 5 over 2. We're not dealing with a word problem that's measuring distance or time. It's just a pure math problem. So we get a nice solution set of negative 5 over 2 and 1. Hopefully that's what you got. All right, next we're going to focus on the discriminant. Now the discriminant is a piece of the quadratic formula that allows you to understand and quickly see how many roots are going to be in this particular function. In other words, if you were to graph this, it would be how many times the graph touches the x-axis. Remember, our choices are pretty limited. Be aware, of course, that there are different ways to ask for the discriminant, and you will be asked these both in the unit tests and benchmarks and CSTs and high school exit exams and SATs and Algebra 2 tests and so on. They're going to ask for solutions, they're going to ask for x-intercepts, they're going to ask for roots, and they're going to ask for zeros, and all those words mean the same thing. They all mean the same thing. So, find the number of x-intercepts for the quadratic equation. Of course, we could say find the number of roots, or find the number of solutions, or find the number of zeros. If we take this and we recognize A, B, and C, and let's just plug it into our normal quadratic equation, remember too, you're only looking at the discriminant here. So even if you plug it all into the quadratic formula, you're just going to look at the discriminant. So why don't you try to remember how to do that, look back in your notes there, and see what you can do with this. Okay, so how about this? If this is our quadratic formula, which it is, let's go ahead and plug the B's, A's, and C's in, and let's see what we get. Notice what's in red here. What's in red here is the discriminant. That's what we're focused on. So if we were just to excise that out of the formula, and let's evaluate this. We have 1 squared. We know that's 1. Multiply backwards, and I think you'll see we get 1 minus 8. Now, of course, if we were to evaluate that down, we're going to get a negative 7. What does it mean when we have a negative discriminant? Well, that means that we have 0 x-intercepts, 0 solutions, 0 roots, or you could say there are no zeros, or no x-intercepts, no roots, no solutions, and so on. And what this means is, in picture form, is if we had a xy plane and we drew a function, then this particular one might look something like this. Okay? You'll notice that the function here does not touch the x-axis at all. So there's no roots in this particular equation. All right. Now, to remember this right here, please. If the discriminant is positive, there are 2 roots. A little bit of a stretch here for the t and the t for 2, but if you can go with it. If the discriminant equals 0, well, that looks kind of like a 0, like an O in the word 1, so there's 1 root. And if it's negative, there are no roots. Negative would be no roots, just like we saw in our example there. All right, now how about we try to solve some motion problems. Motion problems have to do with something moving, either falling out of the sky or being tossed or thrown or whatever. In this case, let's look at a flare shot from the deck of a ship. Now, the function here given to us at the bottom shows us the flare's equation modeled by that h equals negative 16t squared plus 104t plus 56. Find the time it takes the flare to hit the water. And of course what that means is when the flare's height is what number? Well, when the flare's height is 0, because when it's hit the water, it's no longer in the air, it has no height. Okay. All right, now it's going to be important for us to be able to dissect the equation. Remember that h is going to be the height of the flare at any given time. So if someone asks you, well, after 1 second, how high is the flare? You plug a 1 in for t and solve for h. What if they want to know the height after 5 seconds? Well, plug in a 5 for t and do the math and solve for h. This will tell you how high it is. So that's the height of the flare. The negative 16t squared, well, this is the force of gravity on any object in feet per second. Okay? And the two ones that are a little flexible here, of course. The initial velocity, this is the speed at which the flare is leaving the gun. And the constant here, 56, this is the height at which the flare was shot. 56 feet above the water line. Okay? Now, just a little hint for you here. You're going to need to recognize this one on your own and this one on your own when it comes down to some kind of testing. They're going to ask you, whether it be on a formal test, I've seen this before, on the formal test or a benchmark or something, they're not going to necessarily plug those numbers in for you. You're going to have to do it yourself. So please recognize that the linear term here is the initial velocity and the constant is the starting height. Alright, now let's answer the question. So, the question is, let's consider how high the flare is when it hits the water. Of course, it's at 0. We've said that. Take a look at the function. If it's possible, it'd be good to reduce the numbers. Now, if you don't see it, then don't. You can use the quadratic formula no matter how large the numbers are, especially if you have a little calculator with you. Makes things easy. I kind of recognize that there's something here they have in common, which is -8. So I'm going to extract a -8. One of the things I prefer to do, it's not mandatory, I like to have a be positive. So I pulled out a negative number, which reversed the signs here, which gave me a positive a. Now my numbers are smaller, and I'm going to use the quadratic function. I'm sorry, the quadratic formula to solve this function here for 0. Alright, so let's plug this in. A is 2, B is -13, C is -7. So why don't you give that a try and see what you come up with. Even if you didn't factor it, we should come up with the same answers. Okay, so A is 2, B is -13, and C is -7. And if you had the -16 here, and the positive 104, and the positive 56, if you didn't factor out that -8, we're still going to come up with the same result. So let's just see how it goes with these smaller numbers that I chose. I'm going to plug these in and go to work here. 13 plus or minus the square root of 13 squared minus 4 times 2 times -7 all over 2 times 2. The key here, of course, right here, multiply backwards, please. So we end up with 13 plus or minus this radical sign. Go ahead and clean up what's inside the radical there. 169 plus 56. And you're going to come up with 225. Now again, if you didn't factor out a -8, then your numbers will be different here. But in the end, they'll be the same. 13 plus or minus 15 over 4. Where'd the 15 come from? Well, that's the square root of 225, yes? Okay, break it into two problems. And just do your math here. We end up with 28 over 4, which is 7. And I'm going to end up with -1/2 here. Now again, we're asking about time now. Time the flare is in the air before it hits the water. Is it possible to have a negative time? Well, the answer here is no. So we're going to call that an extraneous solution. And so how long is the flare in the air before it hits the water? 7 seconds. All right, so hopefully you got all the way through that, and we both have the same answer, yes? All right, so in summary, be able to dissect the problem, especially know initial velocity and initial height. Simplify if possible. Okay, it's not necessarily mandatory, but it'll make things easier if you do so. Decide what you need to find. Are we finding maximum height of something or the time to 0? Most of the time at this stage of your math career, you're going to be finding the time to 0. 0 height when something hits the ground, when something's no longer in the air, those mean the same thing. And finally, use the easiest method to solve. Okay? Quadratic formula will work all the time, as long as your function is set equal to 0. Alright, now solving area problems. Area problems have to do with geometric shapes, whether it be rectangles or squares or circles or whatever. Squares, rectangles, triangles, and so on, sorry. Rectangles and squares, of course. All squares are rectangles, just not all rectangles are squares. Alright, let's try this one here. It says the length of a rectangular garden is 6 yards greater than the width. The area of the garden is 72 square yards. Find the dimensions of the garden. As soon as you see the word rectangular, what should we do? That's right, we should sketch it and fill in what we know. Well, we know from 5th and 6th grade that width times length is going to be our 72. So width, we don't know anything about the width, it's just the width, but we know something about the length. And what is it that we know about the length? So try to put this puzzle together now. It says it's 6 yards greater than the width, which simply means the length is the width's distance plus how much more? Plus 6. Plus 6. So instead of multiplying width times length as in L, let's multiply width times W plus 6. That'll give us one variable to work with, which we can of course use the quadratic formula to solve for. So let's take this and let's use this fact right here. W times the quantity W plus 6 equals 72. Alright, now back to 7th grade. What do we do with that W out in front? Well, we're going to use the distributive property to take it all the way through. Now from here, do your best to answer this one on your own. Remember the key here, distribute and set equal to 0. Alright then, so how about this? Did you start by distributing W, so we should have W here times W is W squared, W times 6. Now, no real help yet, but how do we get 0 involved? Well, couldn't we subtract 72 from both sides? And that would give us this, because what we do here is we take the 72, we subtract it from here, and subtract it from here. Combining like terms, we don't subtract it from either of the W's because there's no W in it. And now we can go to work. Now if you look at this and you say, well, how can we solve this? Well, we got several choices now. Quadratic formula always works. Maybe you want to easy x. Maybe you even want to use the negative b over 2a and double that result. But what I'm thinking is, I'm just going to use the quadratic formula. You may find another way to solve as well, of course. I know the quadratic formula will always work, so I'm just going to use that, and I get 1/6 and negative 72. So why don't you go ahead and give it a try and see what you come up with. If you want to try easy x or some other method, go ahead and do that, and I'll finish this, and we'll see that we got the right answers. Alright then, how about this? Did you take B and plug a 6 in there? A, you should have plugged in a 1, and C, negative 72. Do some careful math there. 6 squared is 36. Multiply backwards, you get 288. Add them together. Add those guys together, and we end up with 324. I hope 324 is a perfect square. I think it is. Take your calculator, punch it in, and you're going to get 18. So you have negative 6 plus or minus 18 over 2, and now split it into two equations and solve. Okay, so we end up with 12 over 2 is, of course, 6, and negative 24 over 2, which now I'm thinking about it. I'm thinking about distance here, distance solving for area. Can we have a negative answer? Of course, the answer here is no. So if it turns out that our width is 6, what must our length be? Well, we kind of give it away there. But remember that the length was 6 more than the width. So if the width is 6, then what does it tell us about our length? Our length must be 12. Yes? And of course 12 times 6 is 72. So most of these area problems are the same. Just keep the fundamentals. You know how to find area of a rectangle. Replace, they're going to give you one clue to solve. Plug that clue in that they give you. You're going to end up using the distributive property. And always the trick with quadratic formula is set it equal to 0. Alright, and finally the deriving the quadratic formula. Now this is something we talked about recently, and it is a high peak in Algebra 1 of understanding a proof for the first time you're seeing it, okay? So here we go. Let's go ahead and go through this one time. Mathematical proof is a formal series of statements showing that if one thing is true, something else necessarily follows from it. So the question is here, how do we go from the general form of a quadratic equation to the quadratic formula. So here's the quadratic equation, and we're going to end up, after we do these steps, with the quadratic formula. That's our song. Well, how do we go from there, from here to there? Well, this is exactly what we're going to do. The first thing is we're going to get rid of the coefficient in front of x squared. So we're going to divide everything through by a. Now, of course, this a out here, right here, and this a here will cancel, right? And 0 divided by a, well, 0 is our best friend in Algebra 1. He's not affected by a. He's just going to stay 0. All right, very good. Now, the next thing I want to do is I'm going to start thinking about completing the square here, which means I need to move this value to the other side and make room. So I'm going to subtract c over a from both sides. Okay, now then, after I've done this, I'm on my way to a perfect square trinomials. What I need to do now is make room for what goes right next to it. And this is where things get a little tough, because remember that this is the value for c here. So how do we find c? Well, back from our notes from previous lessons, c equals what? C equals b over 2 squared, correct? B over 2 squared. Okay. So I end up taking this b here is actually the coefficient of x is b over a, so it's b over a, sorry, there's a divided by 2 there, and I'm going to square it. And I have to do the same thing to both sides here. So I'm going to add this positive value to both sides. Okay, now what happens right here, and the reason we can go from here to here, from this spot here to this, the reason is that this is now a perfect square trinomial. So we taught you perfect square trinomials a long time ago, and this was why. So this is one of the reasons we can do this, is because this guy here, remember perfect square trinomials look like this. Here's an example of one. X squared plus 6x plus 9. Remember that this would be x plus 3 times x plus 3. Okay? So that's why this is a perfect square trinomial. And we end up writing this as x plus 3 squared. So if this were equal to something, then it would be equal to whatever that was. Okay? All right. Now that we've got this square here, and what we did was we applied the exponent of 2 to b squared, and 2a squared is 4a squared. I think the next thing I want to do here is come up with a common denominator. Okay? And then we'll deal with this, getting rid of these this exponent over here. So common denominator, 4a squared, a. Let's go ahead and multiply top and bottom by what? Well, this guy has an a, he has 4a squared. Multiply top and bottom by 4a, and here we get our negative 4ac. Now, back to 6th grade, if we have common denominator, we can combine these, right? So it's just going to be b squared minus 4ac, and that should start sounding familiar to us now. So you're going to see this denominator here collapse into 1. So notice that this denominator right here, 4a squared, something over 4a squared minus something over 4a squared, is just the numerator subtract itself over 4a squared. But now I've still got this exponent up here, and I need to get this down. I don't want this times itself, I just want this alone. So what's our inverse operation of squaring? Well, that's going to be to take the square root. Remember, if you take the square root of one side, you have to take the square root of the other. So once I take the square root of this, the 2 and the square root cancel each other out. The square root of the denominator becomes 2a. The square root of 4, square root of a squared, give us 2a. This guy has a subtraction, so we really can't touch him. Just leave him inside the square root symbol. The last piece, of course, is to get x alone. And that was the goal to begin with, was to get this x so we can have the quadratic formula. So what's the opposite of adding b over 2a? Well, it's subtracting b over 2a. Notice that the 2a's are going to have a common denominator, and so look what happens. The denominators collapse into 1, and I have negative b plus or minus the square root of b squared minus 4ac all over 2a. Sorry to say that it doesn't get much cleaner than that. I know it's a little messy. Also, there will be an expectation that you understand most of the steps in the order in which they come. The state of California asks us to teach it, and that you understand it and can absorb some of it, if not all of it, which would be great. And they will ask you about it later on, that's for sure. Okay, so please be ready for a unit test. Recommended. Remember, bring a 3x5 note card with anything you want on it for the test. At the end of each unit video, there's a web address for digital practice. Open up your notebook. Maybe you circle stuff that you think is important, or that was maybe a struggle for you to remember. Put that on your note card. Maybe even something to do with that proof there that you just saw. All right then. Hope you found this beneficial, and we'll talk to you soon.